The sine rule. The sine rule is used to find unknown sides, lengths, or angles. Here's the sine rule for this triangle over here, and I'm sure that you guys already know this. It's length A, which is opposite angle A, divided by sine of angle A, which equals length B, which is of course opposite length B, divided by sine of angle B, which equals length C, which again is opposite length C, divided by sine angle C. Now you can use one or the other, it doesn't matter. Remember, these are just letters, we can interchange them, it means nothing. All we need to do is use two. So whether we use these two or the other two, it doesn't matter at all. There's the proof there. I won't go through it with you, but I suggest that you have a look at the proof and how to get it. Example 3 says, find the sine, use the sine rule to find the length AB. AB, so we've got angle C here, it's there. So because we need to find length C, I'm going to write C divided by sine of its angle equals, and the other one that we've got is B. B divided by sine of its angle. Oh, I should say sine B. Now I'll fill it in, so I've got C divided by sine 31 degrees equals 10 divided by sine 70 degrees. And because we're finding C, we've got to get rid of this, which means it becomes times on the other side. So I've got 10 divided by sine 70 degrees times sine 31 degrees. So therefore C equals 5.4809. To two decimal places, we'll say the length AB is 5.48 centimeters, correct, to two decimal places. Example 4, use the sine rule to find the magnitude of angle XZY. So this time we're finding the angle, and XZ is that angle there, Y. So this time I'm going to write sine Z first, because that's what I'm finding, and we can do this divided by the length Z or equal, and I've got angle and side there, which is angle Y, so sine of Y divided by the length Y. So filling it in, I get sine Z. And the reason I do this is because we're always going to be multiplying to get rid of this bottom one. Divided by 6 here equals sine of 25 degrees divided by 5. So therefore sine Z degrees will equal sine 25 degrees divided by 5 times 6. Now we need to get rid of sine, and we're finding an angle, so the only way to get rid of sine, of course, is to do, that's z to the negative 1, inverse sine. So I'll be inverse sine of all this sine 25 degrees divided by 5 times 6. I can just write that on the numerator. So z degrees will equal, and when I work that out, it is 30.473 or 472 centimeters. Now if Z was an obtuse angle, so say like this, okay, an obtuse angle there, then what we would do to find the Z degrees is go 180 take away that 30.473, so we will get 149.53 degrees. And this one to two decimal places 30.47 degrees.